Hey guys, we're headed to Kula today. Got a well pump water meter we need to get integrated into a control system. Should be pretty easy. It's just got a 4 to 20 output and a pulse output. We'll be connecting to a PLC and looking at the raw values and raw data coming in from the water meter and making sure that our scaling is correct and that everything makes sense. We did some work with this customer replacing their well and replacing all the starting equipment for their well, and part of that we had to move and reintegrate how the water meter connects to their SCADA system. So everything's pretty much done except for getting this water meter working. So yeah, we'll get there and get the laptop set up, get it all wired up, and see what's going on with this thing. All right, we'll see you there. All right, we're here. Got my Ethernet connected to the PLC. Just got to pull up Do More. We're using a BRX from Automation Direct. They're nice. Not very expensive, but they work good. Let's see here. Okay. So we're having a hard time connecting. So I'm going to look up the IP address of the PLC in our wiring diagram. The PLC is 192.168.144.2. And so I need to make sure my laptop is on the same IP network. So to do that, we go network settings. And then we go, where is it? Ethernet. So currently I'm on 192.168.1.50. That's not going to work. So we're going to edit my IP assignment. And we're going to go 192.168.144, just like the PLC, but then we're going to be on a different final address. Let's do 50. The subnet mask is good, 255.255.255. The gateway, we've got to change that to 168.144. 192.168.144.1. And then that should be good. Okay, we'll save those settings. Just minimize that, and then we can rescan for new PLCs. Let's try just opening the software again. And there it is, 192.168.144.2. We can click on that, hit connect. We can name the link. We'll call it customer's name. Yeah, we'll just abbreviate it. Oh, it's on 2.9, so I can't use 2.62. So that's 2.6. Here's 2.9. We've got older and newer versions of the software, depending on where the PLCs are located or how old they are. So let's open up the new software. Do the exact same thing, connect to PLC. There it is right there, 192.168.144.2. Connect. We'll call it, abbreviate it. Good. Okay, now we're reading. Very good. So now I've got my whole, the whole PLC program is here. all the different programs within it I can look at: pump, scheduler, tank program, water meter 2. Let's look at water meter 2. Currently, what are we doing? Water meter totalizer, high alarms, low alarms. Water meter total. Calculate the water meter total. Okay. Well, I'm going to pull up, let's see where the water meter is landed currently. So right now, the pulse coming into X1. Yeah. Okay, so then we can pull up data. We can monitor live data on here. We go data tab, pick the element we want to see the status of. So I should just be able to hit X1 and it's off. Okay, and then I want to see, I also have a 4 to 20 input on the water meter for the flow rate. And that is WX3. So let's look at WX3. WX3. And that's interesting. It's 16,383. That does not seem right. There's no flow right now. If I lift the fuse, it drops to 2,000 and then maxes out. Yeah, that is not right. What would be causing that wonky reading? Let's get my 4 to 20 milliamp tester and let's see how many milliamps we're getting on the actual signal. That'll help us understand. So this is a Fluke 789 process meter. It does just about everything I need for 4 to 20 and control stuff. 95% of the analog stuff I use is 4 to 20 milliamps. I rarely use 0 to 10. So what we're going to do is take off our signal wiring. This will just help me rule out anything with the wiring here. I've got something wrong here. But if it's identical here if it's identical on the PLC, which I'm seeing in the computer, and it's identical here, that makes me more suspicious of the instrument in the field. So we're going to set this up for loop power and signal in. We're going to set our probes to source mode. So this is the source. And then we just go over here to loop power, the last one. Yeah, that's not good. It's showing 3 milliamps, almost 4. That is suspicious. Makes me suspicious of the wiring, although really at this point it should be about 0 where it's at. It'd be really interesting to turn the well on and see if the flow changes when there's physical flow, because right now there's no water moving out there. Yeah, let's turn on the well and see what happens. That'll just give us a data point to go off of. Let's put 2 in remote, or no, sorry, local. Start. Let's go see if our flow changes at all. Okay, there it goes. It's going up. 13%, 14, 15. So it seems like the analog signal, our 4 to 20 milliamp signal from the well is working. If I had to guess. We were at 0 before with no flow, and now we're at about 20%. That's a 20% of the maximum range of the signal. I don't know what this meter is off the top of my head, but let's say, 0 is, the range is 0 to 1,000, then 4 milliamps would be 0 gallons a minute, and 20 milliamps would be 1,000 gallons a minute. So if we're at 20% of that range, we would be at 200 GPM. I don't know what that range is necessarily, but we are at 20%, and we can go look at the actual physical meter. Here's our physical water meter. It's showing just over 100, 110 GPM. Very good. Everything else looks good. So the fact that I've got a realistic reading on my milliamp sensor and an unrealistic reading on my PLC, program, the raw input, didn't make any sense. That makes me think that there's some kind of wiring mistake here with how this 4 to 20 milliamp signal was landed. Because right now I've isolated it. It's just water meter to fluke 789. There's no other variables involved. It's just a simple analog loop circuit with this as the source, showing me 20% right now, which is about 100 GPMs. I also see we have a pulse output. It's not a high-speed pulse, but it's still a pulse. X1 is our pulse output, and it is changing state from off to on. Now, I don't know if that's accurate. We'll find out here when we get Josh involved, but it is something. Okay, so we're at 20%. Let's go ahead and turn this guy off. Now let's see if we can figure out why this analog circuit is giving us such faulty information. It was wired up in here. Let's see here. So first thing I'm going to look at is the common for WX. WX are my analog inputs. So in the back here on the bottom, those are all my analog inputs. So we've got this common, which should be connected to DC negative, and it is. That's good. And WX3 is what we were using. And then we are using WX0 already. I believe that's the other wells. We have 2 wells here. And he's wired exactly the same. That is suspicious. So the wiring looks okay. It basically runs, let me show you a basic analog loop here. We got power supply. It's positive, negative. Draw it here and then show you. Then you got it goes out to your device, in this case TD XR transducer, which is our 4 to 20. Then it's going to come back from him and go into our analog input. In this case, we're using WX3. So that's our PLC. And then the negative, or the common of our analog input, in this case is going back to the negative of the original power supply. So it goes power supply, which in this case is our DC power supply in this 24 volt DC power supply. We're taking a positive. We actually have something I didn't draw in here, which I could, is a little fuse. We have our positive fused. It goes out to the flow meter transducer, our 4 to 20 signal, comes back, goes into the PLC. The PLC measures the amount of current, and then the circuit is complete by this negative back. And that's correct. That's how it's wired. So let's try plugging it in. Let's try plugging it in and seeing what happens again to that raw value WX3. You know what it could be? Let's plug it in and let's check the configuration of WX3. Yeah, that analog input. Let's see what it's configured for. Configuration. System configuration. Alright, and then let's go input outputs, or no, it is BRX local IO, analog, WX3. Oh yes, that's why. WX3 is not set up yet. So WX3 we're going to do 4 to 20 milliamp. There we go. Set all that up. And we'll set up enable scaling from WX3 to RX3. Good. There's our mins. So our raw value minimum is 6,553 and our raw value max is 32,767. And then our scaled min and scaled max, that I don't know. We need to find out what that max is, but let's just keep it at 100 for now. Okay. We'll hit OK. OK. And then we'll hit write to PLC. Yes. Yes. Okay, now our raw value makes a little more sense. We're at 9,000, 10,000. Much better. Okay, so that's why that raw value wasn't making any sense when it was plugged in. The input was still in default mode, which was, I believe, 0 to 10 volts DC. So it did not understand the signal it was getting. Now it's set up for 4 to 20 milliamps, so that seems good. I think the last mystery is going to be what the scaling is for that water meter. We need our computer to know what 4 milliamps is and what 20 milliamps is. Kind of like the ends on your speedometer. You know, obviously 0 is the 4 milliamps, but how high does this speedometer go? Does it go to 200? Does it go to 1,000? Does it go to 500? That way, as we're getting a percentage on that scale, we know what it is in the real world to show on our HMI and to log into our SCADA system. All right, so let's reconnect. It says we're connected. Yeah, good, yeah, we're connected. Okay. Let's let Josh know what we figured out.
Why are you doing it like that?
Hey, I got WX3 all configured for 4 to 20. Everything's looking good. I don't know the scaling of this water meter. That's the only problem. I do know that we're at about 20% with a hair over 100 gallons a minute. So that's probably 550 GPM if I had to guess. I think that's what we...
Well, that's what I have it set up as.
On the other ones, yeah, but I didn't configure it on WX3.
I thought I had. Oh, you're on WX3. I'd set it up on WX2.
Oh, I can move.
Why I wasn't seeing anything.
Do you want me to put it on 2?
No, that's fine. WX3 is fine. Just why don't you configure it while you're connected?
Yeah, just put...
Actually connected. Yeah, it said there's another user connected. You can no longer be connected.
Oh, you can't have more than one party in here.
No, one at a time.
Oh,
But
that
I was happy that you were figuring it out. But yeah, you should.
I'm just gonna set RX3 max to 550.
Yeah, exactly.
Yeah, because we're sure that that's what the scaling is. That's great, and that kind of makes sense too, because 20% is about a little more than 100. So.
And then you gotta search for RX2 in my program. It shows up in one copy statement in water meter 2. You gotta switch that to RX3, and that'll point everything where it's.
Can I go to browse? Is that how you, or find? Where do I do
No,
that?
you just Control F it. Control F RX2.
Okay, found it. Yeah, water meter 2 output, copy that. Yeah, there it is. Rung 2 of water meter 2 program.
Yeah.
That's the only place it is?
That's the only place it is. Yeah.
Okay, so we're gonna change that, or I gotta go into edit mode, huh? Probably.
Yeah.
Yep, edit mode, very good, okay. And the source is now RX3. Good. I'll write all that over. Okay, writing. So we were seeing about 100 gallons a minute, so we could set up our thresholds, fault thresholds. Can I do all that through the HMI?
Yeah, you should be able to. I hope.
I don't think so. It just gives me chance.
You can also just set it. No, you can't. Yeah. So you can set it manually on rung 6 of water meter 2. The program.
Alright, let me see here.
What if you would have cut that cap down? Yeah, so you did this.
Rung 6, he said?
Yeah, rung 6 of water meter 2. You just change that 140 to whatever you want it to be.
Yep. Let's do 100.
And then you're going to have to remove the off instruction on rung 7, and you'll have a flow.
I don't understand that one. Why do I need to remove the off instruction?
Are you in it? Can you look at rung 7?
Yeah, it's right here.
See where it said there's T2 dot done is the
Yeah.
first contact, and then there's ST2 is the second contact.
Yep, I see ST2.
So by inserting that, I made it so that the low flow could never be set.
Oh, this is the bypass. Yeah, okay, it's not, that's our temporary.
Yeah. So you just delete that.
The ST2.
It can be reset when T2 dot done is true.
So just get rid of ST2.
Yeah, get rid of ST2, exactly.
Perfect.
Just
okay. That was your.
over it and hit delete.
Yeah, that was your temporary prevention. I got you.
Yeah, that's the standard.
Accept our changes. Write that. Okay, I think we're all good.
All right. Good.
Thanks. Goodbye. Alright, turns out Josh knew the scaling of the water meter already, so I didn't need to waste time doing that. It's a 0 to 550 GPM. The pulse scaling, that's going to be something he's going to need to figure out. I should call him back. Forgot about the pulse.
What happened?
I forgot about the pulse metering for the totalizer. Do you have the scales for that?
Yeah.
I saw it changing state pretty slowly.
I mean, it's the same flow meter, right?
Yeah.
Yeah, so it should be scaled already. Like we just let me open up my PLC program because I can't remember any of it.
Yeah, I've disconnected.
I'm just looking at it on my computer.
Yeah, it's just we weren't bringing well pump 2 pulse into this thing before.
Right, we were reading it in.
Yeah.
So, I mean, right now, it's a high-speed counter on X1.
Yeah, we're on X1 now.
Yeah, and it's a scaled value, scaled in the PLC. If you go to high-speed I/O, you can see what it is. One pulse is equal to 3.717 gallons is how we have it scaled. I don't know how we came up with that.
Yeah, and I think it's going to be the kind of thing that I'm going to need to just look on the water meter's website.
Yeah, we got
or find documentation that says what the pulse is.
Or there might, I mean, it might be something settable on the water meter, right? What kind of, is it that fancy or no?
No, it's not. It's got no human interface to it.
Okay, yeah, so we gotta look it up in a manual. That's probably where we got this number from, is there's a table.
I'll see if I can open it up to get a better model or serial number, because I was looking earlier for the scaling for the 4 to 20 milliamp signaling briefly on my phone, and I was having difficulty finding that exact model register for that water meter. Finding the water meter is easy, but that register is tricky. So right. I'll see if I can get more information on the inside of it.
The manuals right now. Here's a Badger water meter. Oh no,
that's well one. This is a micrometer or a water specialties, same thing.
Okay. Water specialties pulse transmitter.
Oh, there you go. Somebody already did all this legwork.
I know, huh? Great.
And we didn't throw everything away?
Well, we'll see. There's a wiring diagram. And, no talk about
no details.
Scaling might be. Okay. Well,
I'm gonna look into it.
It's a model TR12-2. Let me just see its high-speed scaling. Model TR12-2 high-speed scaling.
I'll call you back. So hopefully inside of this thing is a little more, maybe a label on the printed circuit board or on the terminals. So the body is called the water meter. The top part where the dials are and the indicators, that's called the register. And then, you know, this thing will put out an electrical signal, but it's just an electrical signal. Our computer needs to know what the scale is. So, you know, what 0 is and what maximum is. And we can define units, but we need some kind of scale. So, in this case, you know, the GPM. But then we need to know exactly, we're also using a pulse coming from this. To do the totalizer, to count up the gallons. So for the gallons per minute, we have a signal, a 4 to 20 milliamp signal. And then for the totalizer, which is the grand total of gallons, we have it, yes, a pulse. Let's see, maybe Josh figured it out before me. Did you figure it out?
Pulse rate, 1 contact per revolution of totalizer sweep hand. Any chance you can convert that into English for me?
Well, there's a small sweep hand here, I suppose. I'm assuming the sweep hand goes around every 100 gallons, perhaps. But I would probably reference a manual for that figure.
Yeah, and what the frick is a contact? 1 contact? Like
that's like a close or one state.
Okay.
I would imagine they mean 1 pulse.
So a pulse per revolution of totalizer sweep hand.
Yeah, the sweep hand is, I believe, the little hand, because these type just point at one thing.
Okay. Well, I mean, it wouldn't be very hard for us to just change the scaling right now and see, I suppose.
Yeah.
Because so basically, I mean, if you're correct that the totalizer sweep hand is 100, then they're saying 1 pulse is 100 gallons.
Yep.
Basically.
But I don't know about that. It seemed like it was pulsing more frequently than that when I was watching it.
What were you watching?
I was watching X1.
Okay, that's fair.
Yeah, and it was going on, off, on. It was going on, off, on, off. Yeah. Yep.
Yeah. Okay. Wait. How about you say it to me in the rhythm it is, and I'll time it. And
Yeah. No, I've got the thing taken apart here. I'm looking at the printed circuit board where the wires terminate. I'm going to take some pictures of that with part numbers on it. And then hopefully, because that's what we need to find the manual for, is for this particular register.
Okay.
The meter I'm not so worried about. It's the register I want to know with detail.
Okay.
So we'll figure it out, and we can't even run it at this point until we get that breaker swap. So
Okay.
let's just figure this out, and then we can program that remotely.
All right.
Cool.
Sounds good.
All right.
Thanks.
Thanks, Some photos of this. And then let's just write it down because it's pretty hard to get that camera to focus. Meter, part number 4140-5. 4140-5. Revision 1. There's another one there. SHM1. Nine 4V-0. Okay. Put this back together. Go. All right. So yeah, got scaling figured out, and once we can get the well back in service, we'll be able to measure the water more accurately and see it remotely. So that wasn't too bad. See you on the next one.